because I is equal to the square root of -1. We can't have square roots in the denominator, which means we can't have I in the denominator. If the expression is simply a monomial, we can simply multiply by I in order to rationalize the denominator. For example, if we had a problem such as this, we would simply need to multiply this monomial with I by another I. Of course, we'll do the same thing in the numerator. Putting that numerator in parentheses, we'll see we have to multiply the I through to both terms. 5 times I is 5I plus 3I squared. Recall that I squared changes the plus 3 to a minus 3. This is because I squared is equal to a factor of -1. 3 times -1 is -3. Similarly, in the denominator, I times I is going to equal -1. Times 4 is -4. And now there's no longer a square root, or an I, in the denominator of this expression. Let's take a look at another problem where there's just one term, or a monomial complex number, in the denominator. Again, we only have one term, so to get rid of the I, we simply have to multiply by I, doing the same thing in the numerator. Making sure we multiply the entire numerator by I, we have 2I minus I squared is -1. I squared being -1 will change the minus into a positive 1. Similarly, in the denominator, I times I is -1, and -3 times -1 is positive 3. We now have rationalized the denominator so that there is no radical, or I, in the denominator. When it's simply a monomial complex number, all we must do is multiply top and bottom, numerator and denominator, by I.